So last session we started the performance tuning, okay. And we were discussing like the cost-based optimizer, okay. So which is the one which decides the plan for the statement, okay. So and for collecting the stats and for providing the stats, we have the script, okay. We have the package, okay. So with which you can collect the stats. And we discussed about what is the what will be the stats like describe DB underscore table. Look, describe DB underscore table. See, here we'll get the number of rows, blocks, how many empty blocks are there. So these kind of information will be updated in this DB underscore table when you collect the stats of the any table. Okay. So and with this, okay, Oracle decides, okay, so which plan it can pick up, okay. So let's see how can we collect the stats, okay. So come, so connect to, oh, so here if you see, okay, so what all using, okay, so here you can see, okay, so we have test two, test customer table, and there is a sales table, and if you see number of stores. Okay. So here one more line you can add, that is last underscore line. Okay. So you can see here, okay, the number of rows, okay, so it somewhere is collected automatically, the rows here. Okay. So I think some automatically some job might have done, but okay. So let's create one more table. Okay, so let's connect the organizer. Okay. So now, uh, so let's start from. So now, what I will do here is check this one. Mm, so this needs a room. So what? So here, okay, you can see here, okay, I kept auto trace on, okay, will generate the plan, okay. So it will give the execution plan. So we in the uh, architecture, so we discussed the execution, right? So if you see here, okay, so this is how the execution plan works. So what it is doing, so it is running the table accessible, okay, and which table? So always you have to read the execution plan from bottom. So the first step is it is accessing the table, okay, and full table access, and the name is test. And how many rows it is accessing? It is accessing 131,000 rows. So here you can see 131,000 rows. Okay, and this is in bytes, 384 kilobytes. And the cost of CPU is 59% percentage of CPU is 2. And here the time taken for the particular act. So this is how, okay, so you can uh, check the plan of any statement. So there are other methodologies also. Okay. So here, okay, so it is accessing the table. Okay. So now what I'll do here is, okay, so and here this is main important thing here. So here you see physical read. Okay. So physical read, okay, nothing is there physical read. Why it is not going to physical read? Okay. Why it is not going to the physical read? So let's say also the okay. So now you come and execute the same step. So here you can see it went to physical read. Previously the physical reads are zero. What is the reason? The reason is this statement I have executed before. Okay. So we discuss when we go to the architecture. So whenever we request for any data, first server process will look the data into the buffer cache. After the parsing, so when it comes to the data, so we know that the data exists in the database file in the block. And when you request the data, first the server process looks in the buffer cache. So if it can't find the data in the buffer cache, then it will what it will do, it will go to the file and it will try to copy the blocks from the file to the buffer cache. So here I flushed the buffer cache, means I want all the data in the buffer cache to be removed, and I run the statement, it will cancel it. So what I'll do is I'll run the same statement. And here if you see the physical reads are zero. It means when I ran now, so what we're actually doing is the server process could find all the blocks in the buffer cache. Okay, so that is the reason why it is not for when it finds the blocks in the buffer cache, there is no purpose of again going to a file and bring the blocks to the cache, right? Because all the data which you requested is already in the buffer. So then it will go directly from the cache and it will get the data. So only logical reads are required. Technical reads are not required. Okay. So and here you can see you byte sent via all these things. Yeah. And here you can see this is the number of the process. Yeah. So next here is okay. So that is the reason why. Okay. So if your data is more, okay, then okay, it will go to the physical bit. Okay. And if let's say all like what is this? It's 384 KB only the data size. Okay. So if you come here, so, so my SGA target is okay. It is taking the memory target. So my memory target is 1472. So the requested data is 384 KB. So it means the buffer cache may be 384 KB of size. Okay. So it could fit all the data in the buffer cache. Let's say you requested the table, okay, which is like 10 GB, 20 GB. So in that case, all the data cannot be there in the buffer cache, right? So let's say you request the data, then what happens? Your buffer cache is 1 GB. Then 1 GB of block comes, then it will be given to the user, then it will be removed, again it will go in the other block. So like this it will do all the data blocks. Okay. So auto you can see like how the execution plan is looking. Okay. So now what is there here? Okay. So if you see here, my data is almost all this one. So what I will do here is um, this is the test table, right? Delete from text. So I'm deleting all the data from okay. So here, okay, so I deleted all the data from test. Okay. So then what I'll do is I will do the commit. And if you see when I did the delete, it has generated the redo. Okay. So if you come here, um, for select, if you see, redo size is 0. Because select doesn't, it's not a change, right? So it won't generate the size. Okay, it won't generate any data in the redo. Okay, so that's why if you look at your redo size, it's 0. But when it comes to the delete, okay, so it's a delete operation. Means it's removing the data. Okay, so it's removing the data means it generates the that changes in your redo block as a redo size. So I will do okay. So now what I will do here is I will select um, okay. So here, okay. So what I'll do here is it process 0 rows, but if you see, it is still showing as 131,000. Bytes are 384. You can see here, right? In the execution plan, it is showing. So what I will do is also come right. This I am flushing the buffer cache again. So I will run the statement again. Okay. So if you see here, again it is doing the physical bit. Okay. So if you come here, this is for delete I think. When you go for uh, no, this will go on. So it did the physical. So it's still doing the physical read. Okay, it's still trying to get the data from the table. Okay, so though the data is not there, okay, means the table is empty, right? If I give no row selected, but still your server process, okay, the server process is reading here still going to physical read. How many 180 physical read is there? Okay, so and here you can see, okay, but number of rows processed are 0. So this is the main thing if it comes to the performance tuning. This is the first thing. The first thing you need to check is how many number of rows are requested and how many number of blocks are read. Okay, so let's say um, you know like whatever the data that we insert that will go into Oracle data block. Okay, so here what I'm doing, okay, I deleted the table. I deleted the data. Okay. Uh, Previously, the data was there in the block. Okay. Let's consider from 181 blocks. Okay. So selecting the data was there. That's fine. I'm getting it. Okay. So come here. Okay. But now when the data is not there, also it is reading. unnecessarily it is doing fumble, right? There is no data. Why it has to do the physical work? Okay. So what we do is we update, we'll generate them, we'll run the stack. Dot gather table stacks. This is for gathering the table stack. Table, yes, executed the stack. Okay. Then what we'll do, we'll execute and see this thing. Okay. So here you see test is 0. But let's again run this statement. Okay. And then come here. It's still doing the physical bit. Okay, I collected the stats. Okay, so it's still doing the physical bit, though the data is not. Okay, here in the, if you see in the stats, here if you say call table name, or so here test it is showing 0 rows, but still you can see the block it is showing 192 blocks it is showing. Okay, so whenever you delete the data, okay, whenever you delete the data, there is a concept called high water mark. Okay, so high water mark is nothing but that is some place, or actually it's a
0506.
pointer to the number of blocks. Okay, so whenever you insert the data, it will occupy the block. Right? Whenever you create a table and start inserting the data, it will create some high water. Let's say your high water mark is at the first block. Initially, you have inserted, you freshly created a table. So then what it will do? It will allocate the block. And you started inserting the data. So when you start inserting the data, let's say it occupied first one block. So then your high water mark will be at the first block. Then you inserted some more data, then it occupied the second block. Then your high water mark will be at the second block. So like as and when you are keep on inserting the data and occupying the block, the high watermark will be keep on increasing. So if you say let's say your table has occupied now 10 blocks, your high watermark will be to 10 blocks. So whenever you select the data or whenever you read the data from the table, so what Oracle will do, it will try to look for the data up to that high watermark. Okay, so up to that high watermark it will look. So if the data is there, that's fine. Yeah. But later what I did is I deleted the data. So when I delete the data, so what happens is that high watermark will not be changed. It will be still at that particular highest block. So and that is why Oracle is doing the scans up to that particular block. Okay. So what I'll do here is let's see, something, I did the truncate. So truncate, what is the difference between the delete and truncate means? Truncate is a DDA and truncate also deletes the complete data. Okay. So delete also deletes the data. So now, after truncating the table, what I'll do here is I will again run the system select star from. So here you can see the physical reach it has done is 2 and number of rows it is showing like 1 row, that is 16 no rows only. 13 by cost is 0. So this is the distance between the delete and sum. The example here. So let's say you have a table of 1 million. Here, like we have like how many? Some simple, only one column, we have one row. So that's fine. I mean, not one row, like we had like 1 lakh. Right? Okay. So let's say if you have 1 million, 10 lakh rows, 20 lakh rows, 30 lakh. And let's say you deleted all the data. Okay. So you deleted all the data. Then what happens? Whenever you try to select the data, it still try to read the prompt. It will unnecessarily offset it. Okay. So this way, okay, you are unnecessarily utilizing it. So you have to find out such kind. So let's take another example. So you have
కోశములను
20 million rows.
శరీరములు
Okay, let's say your 20 million rows have
కలిగి
occupied some
ఉంటుంది
100 blocks.
అవి
Okay.
అన్నమయ కోసం ప్రాణమయం కోసం మనోమయ కోసం విజ్ఞానమయం కోసం ఆనందమయ
Okay.
కోసం
Let's say
విశ్వమయ కోసం
we have
నిర్వాణమయ కోసం
20 lakh data and it
వ్యాధి
is occupying, let's say for assumption, 100 blocks.
అప్పుడు సర్వ అనేది
Like
ఇప్పుడు
100
స్వర
into
ఉంటుంది
8.
వాడిని ఇది
చెప్పు
ఇచ్చారా నాకు
నార్మల్గా
తెలుసు
చెప్పు.
అవును నార్మల్గా ఇంకేట చెప్తున్నారు నేను
So
మామూలుగా చెప్తున్నా
I deleted
నువ్వేంటి అది ఇది ఇచ్చాడు చెప్తున్నాను
some
అంతే కావాలా
in
నువ్వు
20 lakhs. I deleted 5 lakhs.
వ్యాధి
Okay.
పుట్టుటకు
I deleted 5 lakhs.
మూల
Okay.
కారణం
So
మూల
what happens if I delete 5 lakhs? Okay. So in let's say it's 1,000 blocks. So in 1,000 blocks, what we are doing is we are we have deleted the let's say like 5 lakh rows, and from each block, let's say some 10,000 rows are deleted. Let's an assumption from each block. So there is a free space in the block, right? But when you select the data, okay, so still 1,000 blocks you will get. But actually, how much amount of data it is there? It's there only 15 lakhs of data is there after filing. Means maybe it comes down to like 800 blocks or 700 blocks. Actual, if we turn out the amount of data and number of blocks. Okay. So, but still, okay. So we have 1,000 blocks. Okay. So, and high water mark will be not set, and you cannot do truncate or find it, right? Because truncate only works on complete table. Okay. So it will delete all the data. So you cannot use the where class with the truncate state. So in that case, so how do you handle it? So this what exactly we call this. So we call this as a fragmentation. Okay. So fragmentation means out of 1,000 blocks, the data is splitted across this block, and there is a free space which is unnecessarily left. Okay. So actually for 16 lakhs, you see 700 blocks may get off. Okay. But still 300 blocks are fragmented. Okay. Because of fragmentation, we get still the 1,000 blocks. Okay. Unnecessarily we are reading 300 blocks, which is not required. But how we can find it? So this is for like 20 lakhs. Sometimes we have some huge amounts of data, not like 2 million. This is 20 lakhs, just 2 million. Okay. So let's say if you go to the bigger table like billions of tables, so it will cost you a lot. So in that case, what you can do? Yeah. So you have to defragment the data. Okay. You have to defragment the data. Okay. So let's come here. Okay, in our example. Okay. So I will create. I will again insert the data. Insert into S. So I did the insert statement. Okay. So how many physical leads we got? We got 440 physical leads now. Okay. So we will discuss like how many rows this many rows passes and it generated the redo. Okay. So here what I do, okay. One more important thing here you check here is um, do we need the redo generation required? Okay. So you can see here redo is generated. Why do we need the do we need the redo here? We have a table. Why redo is generally required? What is the purpose of redo? The purpose of redo is to generate the redo log. And why we use that redo? We use that redo for recovery purpose, right? So here there is a table test, okay. But if I lose, I'm inserting the data in test. Insert into test. Select start from test. Okay. So here, if let's say my insert fails, okay, let's say while I'm doing the insert, so what happens is, let's say crash happens. Okay, just assume crash. So in that case, do I lose the data? I lose the data. Definitely, I lose the data from test, but I don't lose the data from test two because test two table. I'm just reading the data. I'm not modifying the test two data. So instead of generating the redo, because always the redo generation will take time. Okay, means it has to do some redo, means generate the data, and log fixation happens. All that internally it will take some time. Okay, so okay. So what I'll do is I will go that complete. Let's start from okay. So now nothing is there. One row, okay, this much. Okay. So now what I'll do here is that I'm on. Okay. So insert into test. Select start from. Okay. So it generated the redo. What I'll do is what I'll do is same insert pen. Okay. And insert into test. Uh, so it is also generating the redo. So what I will do is roll back. So what it is doing? So cannot read modify an object modifying it in parallel. Okay. So it says cannot modify an object after modifying it in parallel. Error generating. Okay. So this is not the actual plan. So there is some issue with this. Okay. Let us come. Let's discuss this later. Okay. Now how much data is there? So let's down from test. Okay. So how many rows are there? Okay. So this is 131072 and physical reach it has done some zero sizes 132. But here if you see in the explain plan it still shows rows 1 because if you come here my stats are 0 for this. Okay? Here the test table is 0 it is showing. If you come here it is having the data, right? We select count of from test. So it is having 131074. Okay. So what I'll do here is again I'll connect the stats. Like I will collect the stats from the text table. So you saw now, right? So the stats are not collected automatically. So whenever you do some bulk load, okay. So here I did some how many 1,30,000 rows I have inserted, but if you see the stats, it is showing in the stats the previous table is 0. So it means the stats are not correct, and your execution plan may not be proper in that. So what I will do, I will collect the stats now and let's see here. Okay, number of rows, number of blocks, I need to from 4. So now come here, yeah. So, but here if you see, test2 table is occupying the same number of rows, but its number of blocks is 2. Test table is also occupying the same number of rows, but if you see, the number of blocks is doubled. Okay. So if you see here, so all are in the users table. So come here. Okay, so what I'll do here is again I'll flush all the system, flush, flush. Then what I'll do, I'll come here. See, it's going to 426 physical routes. Yeah, this start from text. See, it's going 422 physical routes. The actual size, if you take test2 table, it is only 212 blocks. But when it comes here, it is going for 440 blocks. So now it means it is occupying more blocks. What I will do, also table. So alter table test, I am moving the table. I am moving the table. Then let me collect the stats again. let's see here it has come to 190. So now I will select from here. We'll do block. Flash the buffer cache once again. And here it is taking 182 physical. So here you can see 440 blocks it has occupied before, and I ran the move statement. So what it will do, move statement means we can use this move statement whenever we want to defragment the table. So the 440 blocks, when I inserted, okay, the data, so what it did is previous 220 blocks it was there, and now the when I did insert, it occupied another 220 blocks. So almost 420 to 440 blocks it has occupied. But if I defragmented, if you see it has come to around 190 blocks. It means if you end up in such kind of state, okay. So normally in the real time, what we'll do, so let's say there is a table of 50 million rows or 60 million rows, and you deleted like 10 million or 20 million, then there will be a lot of fragmentation. It means 60,000, I mean 60 million rows might have occupied 1000 blocks, okay, but after deleting 20 million rows, means after deleting 20 million, it will be 40 million. But still, for 40 millions also, it will go for 1000. So in that case, what you have to do is you can reduce the fragmentation. This is called as defragmentation. So you have to find the fragmentation. Okay. So usually when such kind of things happen, okay, deletion kind of things, you have to do two things. One is collect the stats, and you saw here, right? When you change the rows, that number of rows here is not getting updated, right? So in that case, you have to collect the stats and also try to defragment the object, mainly a table. Okay. So here move statement, okay, alter table, table name, move, table space, use the same table. Okay. So if you see here, it will be in the same table. So if you want to move another to other table space also, you can do. But for that, you need to have the permission on that other. Okay. So that is the reason. Okay. So this is the one of the important. The simple thing is how many rows are being accessed and how many blocks are being accessed. Okay. So in our case, if we took the example, we are getting no rows after deleting the data. For us, no rows. But internally, what Oracle is doing, Oracle is reading all the blocks of the table because of its high working hours. Okay. So if you delete complete table, okay, so instead of delete, you can go with one. Okay. So and if you if you're not deleting all the data, let's say only some amount of data, then you can go with the defragmentation of the table. So just move the table in, in the same table space as other tables. Okay. So and it depends on the table size also. If the table is big, the most statements may take some more time. If it is small, it may take less. Okay. So this is the one of the things, and you saw the execution plan. Okay. So next thing here is, okay. So this is about select star from state. Okay, means you are requesting all the data from the table. So test one, test or test two table. So we have 1,30,000 rows. Okay, so all the rows we are selecting. That's fine. But let's say here we have non-unique. That means all the values are. If we test and test two table, we have all the non-unique values. But what if, okay, let's say there are 1,30,000 rows in my table, all are unique values. Means, let's say employee ID from 1 to 1,30,000 we have. So I want to see, get the only one row from the table. Then what happens? Okay, out of 1,30,000, you have the data. Okay, in current case, what is the first scenario we did? We did that data is removed, but still, when you select all the data, okay, here we are selecting all the data, but the number of blocks will be fixed. That is due to the fragmentation. Because whenever you do any delete statement, the high watermark will be not set. Then in that case, okay, so the server process will try to copy all the blocks. So in that you can decide. That is the first thing. Okay, first scenario you are requesting all the data. Okay, so even though the amount of here in the first is what the amount of data is not matching with the number of blocks, right? So you are requesting like I there are no rows in the table, but still it is reading all the blocks. Okay, this is because of the defragmentation. But take the another scenario. I need only one row from the table. Let's say you have some, in our case, 1,30,000 rows are there. I want only one. So considering all values are unique. Okay. So in that case, one row means it will be in some block, right? So actually that one row, one block is enough to get into the buffer cache. But how Oracle will know that where that particular value is, it doesn't have it, right? So 1,30,000 means here in this case 212 blocks are. So I'm requesting, let's say, select start from test to where employee ID is equal to 100. Okay. So I'm considering we have only the unique value. Means 100 only one value, one row is 4%. So in that case, still Oracle will read all the blocks. But why is it required? We are requesting only one block. Okay, because one row means it is there in the one block only. So my for my requirement, reading one block will get the value, but still it will read all the. So this kind of scenario also you will face, and whenever you find this kind of scenario, you have to reduce the number of blocks to be read. Okay, so for one row, one block is enough, but for one row it is reading all 212 blocks. I can reduce this. How can I reduce it? I can reduce this by creating an index. Okay. So let's take an example. How the index will be arranged. Same like your book. Okay. Index will occupy space first. If you take your book, you have the index, right? It will be based on the number of topics you put in the index. The size of the index will also increase. If your book is like big, 1,000 pages, your index will also be like maybe at least 10 to 20 pages of index, right? And index, what you will write? You will write the topic name, page number, right? Topic name, page number. So, and by seeing the topic name, you will directly go to the particular page. Okay. So, here also the same thing in Oracle. So consider your normal book pages as blocks, okay, table block, and index as an index block. In index block, what information will be stored? It will store the in here instead of page number, it will store the row ID. Okay. So row ID is the physical address of the row. So if you see how many rows are there in this? Okay. Here also I so select ID. So here you can see row ID is a column which is a pseudo column kind of. Means it won't be there in the table. So you can select. So row ID is a physical. So physical address means like mainly a data file, block, and the particular. It's just like your house address. Okay, your house address, what will be? Will be like state, okay, or the area name, street name, and your house name. So here when it comes to a database, okay, it will be like data file, data block, and in that block, where the code. So this is how, okay, so your row ID will be there. So when you create an index, so usually you create an index on row, on column. Okay. So what it will do, it will store the value of the particular column. Okay. So let's take an example of like, so we'll connect to the database. Okay. So let's take the employee. Select, describe, so select employee name. That is it. Okay. Okay. So select row ID from rows and long. So here, when I create a, so when I create an index on this column, so in the index, how it will store me? It will store the row value and it will store this row value. Okay. So when I select employee, their first name is equal to Harrison, it will go to the index and it will say Python. And what is the row ID? This is it. Then it will go to the block where the code is table block. Index block will be different, table block will be different. So first it will read the index. So in index block, it will find out the value. So the next question we will get is it will scan the index block. Then how it will be. So you have 1 million rows. Okay, let's say, then does it should it scan the 1 million rows? Okay, for reading the index block also? No. So index will be arranged when you create an index, that values will be arranged in a descending order. Okay. So what happens means descending means in first name. Okay. So let's say A B C D E F G H. Okay. So it will scan like A value, B value, C value, D value, E value, value, G value. Shit it will come. So let's say after H, it will find the I. Then it will stop there. Okay, because if it is arranged in a that particular fashion, after H if you get I, then there is no possibility of taking step back, right? So that is the why. So it will stop there only, and it will get the row ID, and it will go to the table. So it will just say answer. Okay, I am reading the index. In that index, I got okay exactly the how where the block is the table. Then it will go and pick only that particular. So no need of scanning all like thousands of things. Okay, just 3 4 blocks to scan in the index and get that one block. So that is the use of the index. Okay, whenever you have like huge amount of data, and out of that you were requesting only like one or two, let some amount of data, then index will be the best option. And what index is doing, with the help of index, you are trying to reduce the number of blocks that you have to wait to get to it. If there is no index, it has to scan all the blocks. Okay, because in the table, the data won't be arranged in a particular fashion. Okay, means after Harrison, okay, even there won't be any value for Harrison also, it will scan the remaining data because it doesn't know, and the values won't be arranged in a particular fashion. So once you get to a particular value, so it doesn't know to stop. Okay, it will still scan it if there is no. So but if there is an index, so this is a possibility. So number of blocks will be reduced. So this is one thing. Okay, means there is a data, okay, huge data, and you are requesting means there is no fragmentation. But only thing here is if there is no index, you don't know exactly where the value is, or actually doesn't know where the exact value is. So that is the reason why it will scan all the thousand or 2000, whatever the number of blocks are there in the table, it will read all the blocks. But if the index is good, index will make in the scan directly will point to the particular block in the way the okay. And when it comes to the indexes, we have the different types of indexes like B tree, bitmap. Here two types of indexes, and on top of that we create like function based indexes, okay, reverse tree indexes. So there are two things. Okay. So what is the good choice for creating index? Okay, index will always not be, there are some certain things which you have to consider when you create them. So first thing is how many unique values are there in your particular column. That is important. Okay. So let's say first name is there. So in first name you have one or seven. Let's say all the out of 107, 100 people have the first name of John. Okay. John, something like that. Okay. So, and you are looking for John. In that case, maybe 100 rows means Let's say total number of rows are 107, 10 blocks it is on. So 100 rows means maybe 9 blocks it occupies. So you are requesting almost all the blocks. Only one block data you are not. Okay. So when it comes to the, if you build an index on such data, so instead of increasing the performance, it will decrease the performance because anyhow it has to read the 9. If you create an index, it has to read the index block. Then from there it has to find the blocks in the table. So in that case, so what happens? It has to get the it has to be the index block and here 9 blocks. It will increase. So rather than that, if it goes to scanning the complete block, so that will be better, right? So 9 blocks it can get. So this is a very important consideration when you create. Okay, you have to create an index on a column which has more distance value. Okay. So if you create an index on column which is not having more unique values, that is a poor thing. That is a poor choice. That is the first. And second thing here is whenever you create index will be good for read operation, but index won't be good for DML activity. DML means when you do huge changes on the table, okay, and for that index will cause, okay, the performance degradation because when you change the values in the table, those changes should be reflected in the index. Okay. So when I remove, let's say I'm deleting the values from the table, then that should be deleted from the index. And as I said, the data in the index will be arranged in a particular fashion. So when you delete a value, the order of the rows will change. It has to rearrange all the values in the particular order. Okay, so due to that, what happens? Index will also be defragmented. So when you do huge like deletes or huge updates, so due to that, so what happens? First thing is it has to change the values in the index also. That will cause the problem. Means instead of if you do uh, delete, so it has to read the two blocks at the time, right? One block should be from the table and one block should be from the index. If there is no index, it has to do only on one block. So same for delete, same for insert also. When you are inserting the value, it has to get blocks for the table and blocks for the index. If you are updating it, it has to update the table block, it has to update the index. So when you are doing like any more changes, index will not be good on the table. Okay, and even after doing such, let's say you have an index. Okay, and not regularly, maybe once in a month, you are making huge changes on the table. Like maybe you are deleting the old 1 month data or 2 months data in the table. So, and you are doing only one thing, and remaining days you are doing mostly the read operation. So, what you can do here is you can create an index, and what you do after when you are doing some like huge operation, what you can do is you can recreate them. That time, what you can do, you can drop the index when you are making huge changes, again recreate the index. Okay. So that way, what happens? It will increase when you drop the index. It will increase your DML activity, and also if you drop, okay, when you recreate the index, so index will come in the good format. Otherwise, if you put index like that only and do lot of changes, first thing is it will degrade the performance. Second thing is the index will be defragmented. And again, that index will not be good choice. Okay. So sometimes it will cause the issue. So you have to rebuild them. Okay, in that case. So these are the few things which you need to consider mainly. Okay, one thing is more unique value. Second thing is see what all activities are happening on the particular column of table. Okay, so based on that we have to decide. Okay, so today we'll stop. Okay, so tomorrow we'll discuss more about some more things about the index, and then this is whatever we are discussing. This is all about a particular query or a table. So then there are a scenarios where your complete database is there. So in that case, how you can do. So that will discuss tomorrow. We'll complete the index tomorrow and then we'll start the whole database is how you can do.
Okay, sir. Sir, and how to apply the patches to the database? These and all comes under. Sir.
Yeah, that will be. It will be like very easy. That's one comment for applying the patch. Okay. So
Okay.
it, means this process is like, when you apply, these are usually on Oracle database we have like we call as a PSU package, task secretary. So for every quarter Oracle releases this package, PSU package. In that it will have multiple packages. So there will be a utility called patch utility in Oracle. So only thing is you need to shut down the database and apply the patch. That I will show the process. Okay.
Okay.
So and other patches also will be there is one. So one of patch means if you hit any specific bug, okay. So Oracle will release a single patch for that. So the applying will be same, the process. Only thing is here you have only one patch. But when it comes to PSU patch, you have a negative patch in one folder. And the utility you use this process is also okay. So that is okay.
Okay, sir.
You put down
Okay.
okay.
Yeah, yeah, yeah. Okay, sir. Thank you. Sir, hello.
Yeah.
Sir, what about those videos, sir? Actually, did you save those videos in Drive or?
It should be, yeah, I showed in one video. Whenever I thought that it's asking for some storing in a file, forward it.
Okay, okay, sir. Okay. Yeah, okay, sir. Thank you.